From KUNC and the NPR network, this is In The NoCo. I'm Erin O'Toole. In the depths of the ocean, miles beneath the surface, unusual new technology developed by Colorado researchers could soon help scientists make discoveries. At the University of Colorado Boulder, far from the ocean, researchers are harnessing the unique abilities of jellyfish to act as underwater explorers in places humans can't easily go, like the Mariana Trench, 7 miles below sea level.
I think the tools and technologies we have are really great for studying some parts of the ocean, but the main issue is that the ocean is just so vast, and so we really need all the tools and technologies we can get.
Nicole Hsu is an assistant professor of mechanical engineering at CU Boulder. She implants tiny devices into live jellyfish that allow scientists to steer them toward remote areas of the ocean. She talked with me about how her work aims to change how we study the deep sea and how she hopes these cyborg jellyfish will inspire the next generation of underwater robotics. What kinds of measurements or observations will these jellyfish be able to make?
We can put different sensors into the jellyfish, and so one idea is to put pH sensors so we can track ocean acidification over time, or we can put tiny cameras on so that we can see the natural animal behavior of things that we can't get in the lab.
I know your technology is still being developed, but what kinds of ocean research do you think the jellyfish will be able to help with?
So because jellyfish have soft bodies, they can reach certain areas of the ocean that traditional underwater vehicles might not reach because those vehicles are typically larger or made of these more rigid materials. So one example is, can we get these biohybrid robotic jellyfish to swim near coral reefs or traverse through these dark caves that traditional vehicles might not reach?
So are you studying new species or looking for new species in deep trenches or around coral reefs?
All of those questions are really great, and we're really interested in studying a whole suite of different topics of ocean exploration and monitoring. So right now we're not so focused on the sensors, but we're looking into things like miniature cameras and pH sensors.
And what makes jellyfish such an ideal tool for studying the deep ocean?
Jellyfish are found all over the ocean in very deep depths, as you mentioned, in very salty waters or not so salty waters. And the thing that makes these jellyfish really unique is that they are the most energy efficient animal in the world. So we can really study how to make low power underwater vehicles using jellyfish.
Oh, as a model for these machines.
Yes. And just outfitting the jellyfish with these electronics too.
Okay. How challenging is it to fit these microelectric devices into the jellyfish? Where do they attach and then what do they do?
So we put a wooden pin into the animal in the center of their bell where they have the most tissue. And it's kind of funny because you think that with these engineered tools, one of the most challenging things I found was that everything falls out of jellyfish immediately. And so we can use these wooden pins because they have microscopic barbs that hook into the tissue very well.
Oh, wow. So the bell is the main part of the jellyfish body?
Yes.
And so it must have is it slippery on the surface? Why do things fall off?
The jellyfish tissue is very similar to Jell-O. So if you imagine putting anything into Jell-O, it'll just fall right through. There is a slimy surface, but that typically doesn't happen until you take the animal out of the water. And then that's a stress response, so it secretes mucus.
Okay. And so once these devices are successfully attached and not falling off, what do they do?
You can think of these devices like a pacemaker that we put on the heart. So as opposed to sending an electrical signal that stimulates the heart at a certain frequency, we're stimulating jellyfish muscle at a certain frequency. So we're creating it to pulse at once a second or once every 2 seconds in the ocean, depending on what signal we send.
And so how do you use that then? You tell it where to go?
So that's ongoing research in the lab right now. We're currently working on methods to turn the animals, which is one limiting factor of our research. But using this device to control the frequency, we can increase jellyfish swimming speeds up to 3 times what they would normally do.
Before the show, Nicole, you mentioned that ethical research is very important to you. Mm-hmm. I'm curious if the jellyfish feel anything from these microelectric devices. Does it cause them pain or confusion? Why are they suddenly swimming faster?
hmm So jellyfish don't have nociceptors, they don't have pain receptors, they don't have a brain or central nervous system, and so they can't process pain. That said, we're still very careful to make sure that we treat the animals in a humane manner. And so typically invertebrates, which are like jellyfish, they don't have a spine, are not covered under any advisory boards for ethics. But we still try to think of these animals as individuals and what are the considerations towards these individual animals during our experiments. What about jellyfish as a species when we deploy these in the ocean in the future? And what about potential environmental impacts? So, as I mentioned before, jellyfish secrete mucus when they feel stressed, and we're not seeing that behavior. In fact, the jellyfish are still able to reproduce in the lab at Boulder.
I probably don't need to point out to you, but jellyfish are notorious for their ability to sting. How do you work around that in the lab?
These jellyfish have stinging cells, but they can't penetrate through human skin. So we're not too concerned about handling these animals. And in fact, when we have children and general guests exploring the lab with us for our lab tours, we can have them touching the animals too, and they're fine.
Oh, cool. Okay. I want to talk about where the research goes from here. How soon might these cyborg jellyfish be ready for deep sea exploration? And what needs to happen for that to be viable?
We're thinking that we can deploy these animals over the next maybe 10 or 15 years, and that really depends on how much control we have over directing these animals. So the idea is whenever we put an electronic device into the animal, we're pulling it in a certain direction, and it can only swim straight. So using our new devices, we'd like to turn the animals so that we can have them swimming in different areas of the ocean. So the first step for us is developing this in the lab and having the jellyfish swim through an obstacle course. Then we can incorporate controls and have multiple jellyfish working together before we deploy them in the ocean.
Little fleet of jellyfish. I love that. In your lab, part of your research also focuses on the design of new and better underwater vehicles based on the movement of animals like jellyfish. What does that look like, and how will that lead to better deep sea exploration?
We're working on a variety of tools to explore the ocean in different ways. And so one idea is shark skin has these little surface structures called denticles that are similar to teeth. And so we want to incorporate those onto underwater vehicles and these robotic fish fins so that we can create more energy efficient, entirely engineered robots. And then we're working on looking at sea sponges and corals and how we can eventually use them for habitat restoration as well.
Nicole Hsu is an assistant professor in the Department of Mechanical Engineering at CU Boulder. She spoke with me about her work to harness the unique abilities of jellyfish to improve study and exploration of Earth's oceans. We'll include links where you can read more about her research in the show notes and at KUNC.org. While you're there, you can catch up on other In The NoCo science interviews, including the work that insect experts at the Butterfly Pavilion near Denver are doing to restore fireflies to Colorado. That's it today for In The NoCo. I'm Erin O'Toole. Thanks so much for listening.